In question number 5, they're saying that P and Q are two fixed points on an inclined plane. So let's say this is P and this is Q. Okay, and Q is 0.5 meters above the level of P. So if I make it a triangle, this height difference between them is 0.545 meters. Okay, particle is mass is 0.3 kg. Okay, given that the plane is smooth means there is no friction, that means no opposition, right? All right, and that the particle just reaches Q, that means the velocity or speed here is 0 meters per second, just reaches there and stops. That's what it means, just reaches Q. Find the speed. So what was the speed at P? So we can see there was some velocity or speed here, there was some speed here, but during the course of reaching Q there is no applied force. Okay, and there is no friction also, so we should not be bothered about any other type of work. Only thing is that it gained height, so it gained potential energy, but it stopped, it lost kinetic energy. So whatever was the kinetic energy at the starting is same as the potential energy at Q. All right, M and M cancel, V square will be 2gh, correct? And if we square root both sides, it will be 2gh, and let's put the values here. Square root 2 times g is 10, h is 0.45, 4.5 times to 9. That comes out to be 3 meters per second. That was the speed at P. Or 2. It is given instead that the plane is rough. Okay, so the situation has changed. Okay, so this is, let's say this is P and Q is referred, yes, Q is referred here. So Q, okay, the particle passes through P at the same speed, so the V here is 3 meters per second. Same speed means the one we got in part A. Okay, the work done against the frictional force is this, so work done against resistance is minus 0.39 joules. Why minus? Because friction is always against the motion, so that's why I'm writing it as negative work. Okay, the work is not a vector, but because we have to subtract, I'm just to remind myself, I'm writing it minus. Find the potential energy gained. Okay, we have to find mgh by the particle moving from P to R. Okay, where is R? Okay, R is somewhere here because it will stop earlier because there is now resistance, so it will stop before Q. Okay, hence find the height. Okay, we know that change in kinetic energy plus change in potential energy is same as work done by applied force minus work done by resistance. Okay, this difference in kinetic energy, the velocity at the starting was 3 meters per second and here it is 0. So we know what is kinetic energy, it has reduced. So it will be minus 1 over 2, mass is 0.3 m, V square, V is 3 square. If there was a value here, then we would have bothered to find it separately, but since it is 0, just put this and that is the loss. Okay, plus, because first part they're saying find potential energy, so I'll write just delta PE. I will not put any value in this. There's no applied force, it just passed P with 3 meters per second and in between there was no push or nothing, so it will be 0, and we know that 0.39 is the work against this force. Alright, so we have everything ready with us. Let's bring this to the other side. So delta PE will be positive half 0.3 and 3 square minus 0.39, and let's put this in calculator. That will be 1.35 minus 0.39, which is 0.96 joules. This is the gain in potential energy. Now they're asking the height of R above P. Yeah? So basically if R is here, they're asking this height. So we know potential energy mgh is 0.96 joules. So m is 0.3, g is 10, h is h, and 0.96. And this will become 3. Okay, so h equal to 0.96 divided by 3, which is 0.32 meters, and that makes sense. It is less than 0.45. So this is the height it gained.